My wife and I have always wanted a workspace like this, so for the last year, we've been building one in our backyard. We're going to use it as a home office as well as a workshop for our small business. With the structure already complete, as well as the rough electric installed, we're finally ready to build out our interior. The space will be fully finished with insulation, climate control, and vaulted cedar ceilings. We'll take you through the entire process, step by step, and share material quantities, project costs, and detailed animations. We're self-taught and doing all of this ourselves on nights and weekends. We're going to try to give you all the tools you need to do this yourself. By the end of this episode, we'll have our space ready to use. In fact, I've already been using my new desk out here to edit this entire series. So let's get started. This video is going to cover the last 4 months of our 11-month project. If you're new to this series, we wanted to start by giving you an overview of everything that we've done up to this point. We started by pouring a 12 by 18 foot concrete foundation, and once that was fully cured, we could begin framing up our structure on top of it. To clad that structure, we're using zip system sheathing on the exterior walls, as well as the roof. And to support that roof, we're going to use a structural ridge beam, which is going to allow us to have a vaulted ceiling inside of the finished shop. We installed a metal roof, along with doors and windows to finish drying in the structure. For siding, we're using hardy board, and we went with a maroon paint to match the brick of our home. And lastly, we brought power to the new building. We buried conduit to bring our lines in on the far wall of the shop where we have a 90 amp sub panel. We've passed our framing and rough electric inspections, and now we're ready to start insulating the shop. I'm going to start by applying a closed cell spray foam to the underside of the roof deck. This acts as a moisture barrier as well as thermal insulation. Without this, the underside of the sheathing will be susceptible to moisture issues in the winter. Condensation will form on that cold surface as it interacts with the warm, humid air inside of the building. The product I'm using is made by a company called Tiger Foam. They ship it to you as 2 parts, each in its own propane-sized tank. The attached sprayer mixes these 2 chemicals as it's applied. This stuff is pretty nasty, so you'll want to make sure you use a respirator and a Tyvek suit. There's a little bit of a technique to learn with the spray gun, but after a few sections, it's not too bad. I purchased a 600 board foot kit, which means it should yield 1 inch of thickness across 600 square feet. On my ceiling, I ended up with 2 inches of spray foam, which on its own has an R value of 14. This will increase once we add the Batt Insulation here shortly. But before that, I had a few quick things to add. I'm going to run 2 different Ethernet lines so we can have wired connections at the computers. These lines are going to run 12 inches above the electrical so I can avoid interference. I'm also planning ahead for my eventual desk setup. I'm going to place a few boxes ahead of time so that the monitor and the computer can be wall mounted with no visible wires. I'm currently using a custom water-cooled PC to edit and animate this series, but once the shop is finished, I'm planning to build a wall-mounted version to free up desk space. Stay tuned as I'll be making a video for that project in the near future. I'm also running an HDMI cord from my desk over to the eventual TV location. With all that in place, I was ready to start adding rock wool insulation. I'll start with the walls. I'm using an R15 batt that's sized to fit in studs that are 16 inches on center. After I have it out of the bag, I'm tapping the edge to help the batts regain their original shape. The stuff installs pretty easily. It's slightly oversized for the wall openings, so it fits snugly in place. You just want to make sure that you don't over compress the batts. They should be flush with the studs and not pressed in any further than that. It's super easy to cut this stuff using a serrated insulation knife. You can even use the edge of a tape measure to score the cuts before cutting all the way through. For the corners, you can see that I'm sort of notching the edge to fill in all of the cavity. You have a few options for installing around wires. You'll see a lot of people cutting halfway through the insulation at the height where they have their wire runs, and that way they can have a continuous face on the inside while providing a groove for the wires to sit in on the back. I decided to just have a clean cut at each wire run. That way I don't have to worry about getting the wires to sit perfectly in a groove that I can't see. For the ceiling, I'll be using an R30 batt in addition to the spray foam we've already applied. My ceiling joists are 9.5 inches tall. These batts are 7.25 inch thick. The combination of the batt and foam should fill up the space nicely. I'm also going to take advantage of this opportunity and add some extra framing where my TV is going to mount. This is going to make my life much easier when I go to anchor the wall bracket. Here I'm installing our electrical disconnect for the mini split unit. I'm drilling a 3/4 inch hole through the siding and sealing around this penetration using some butyl tape. Then I'm going to start the process of wiring up this 20 amp GFCI circuit that will power the HVAC. If you're interested in learning more about this process, you should check out my video dedicated to installing the rough electric for this workshop. It covers the whole process of installing the other 5 circuits you can see here. We'll return to this disconnect in a little bit when we install our mini split unit. With those last items out of the way, I was finally ready to close up the walls for good. With our insulation fully installed, we have an R value of 15 in our walls and 44 in our ceiling. Next, I'm ready to place my order for our drywall. We're going to use 1/2 inch sheets, and I purchased 4 that measure 4x8 and 9 of the larger 4x12s. I came up with this layout to reduce the amount of vertical seams I'd need to mud later on. For this part, it was really helpful having the entire building designed ahead of time. I marked out my cuts using dimensions pulled from my model, and I also have my mounting locations for the eventual mini split. With help from my wife, we were able to get this in a position before securing it to framing using 1¼ drywall screws. I'm securing the sheet about every 12 inches. Using the window frame as a guide, I'm using a drywall knife to cut out the sides of the opening. And then I can just score and snap this piece at the top. While these 12-foot sheets are a little cumbersome to handle, it's nice that I won't have any vertical seams on these end walls. I start with a few screws to hold the sheet in place, and then I draw some guides to help mark my stud locations. For the sections on the front wall, cutting out the door opening before mounting. I took out some material near the window to help make the sheet lighter, and then I'm cutting out the rest of the window once it's in position. I'm using a couple pieces of scrap material to help get the drywall into position with a 1/2-inch gap off the floor. This space helps prevent the drywall from wicking moisture up from the concrete floor. And now we're switching over to the back wall, which unfortunately doesn't have any windows or doors to help us hide the vertical seams. You usually want to start at the top of the wall when mounting the sheets, so you can make sure you don't have any gaps between the wall and your ceiling. Any gaps at the bottom of your wall are going to get covered by the baseboard. We're following this method, but it's not super important in our case, since we're going to have a crown molding to cover any gaps at the top. In each outlet location, I'm cutting 3 sides of the opening with a drywall knife, and then I'm scoring the 4th edge. Then you just need to cut the backing paper to finish it off. Before I'm ready to start mudding my drywall, I'm putting some quickset 45 compound in any large gaps, like this damaged corner. I also have a little bit of a larger gap than I'd like at this vertical seam, so I'm going to add some here as well. With the rough work finished, I'm going to start prepping my drywall compound by giving it a thorough mix. This stuff is pre-mixed, but you'll get a better consistency if you blend it again before use. I'm going to leave my mixing attachment in a bucket of water to help keep it clean. We'll start with a 6-inch trowel and put some compound in our pan. This first layer is going to be the mud that we press our joint tape into. If it's a little stiff, you can just add some water to help keep a smooth consistency. Once the whole joint is covered, we're going to roll the tape across, making sure we have the smooth side facing out. When you get to the end, you can use the trowel to help get a clean tear. I'm going to run the trowel across the tape, applying light pressure to help embed it into the mud. And then I'll add a light layer over top of the tape, trying my best to feather this out at the edges. I'll repeat this process for all of the seams, and then I'll let this dry for at least 24 hours before I start with my second layer. For each screw head, I'm pushing compound into the cavity, turning my trowel, and scraping off the excess. For the corners, it's a similar process, and the paper has a crease in the center to make it easier to fold. For the second coat, I'm using a 10-inch trowel, and I'm feathering the joint out further to help blend the seams. more feathering for the third and final coat. And lastly, we're doing some light sanding before we begin priming for paint. Here I'm putting up the bracket for the mini split while Judy Ann puts the first coat of primer on the walls. I've been looking forward to having air conditioning for months. With the walls ready, I can finally get the mini split in place. First step is building a small concrete pad for the condenser unit. You could just lay down some concrete pavers, but I wanted to get some experience mixing my own concrete, and this little pad was the perfect small job to start with. I'm using a 2x4 with construction screws to build my form. Here I'm using the outline of that form to mark where I need to remove some dirt. Then I'm going to compact the soil a little bit before I fix the form in place. I'm going to center the pad on my shop wall, and I'm making sure I have 12 inches of clearance between the back of the condenser and the shop, so I'll have good airflow. I have some gravel left over from the construction of the workshop foundation, so I'm going to take some of this and add it to the form to help with drainage under the pad. With all that set up, I'm ready to start mixing some Quikrete. It's a small job, so I'm just mixing it by hand in my wheelbarrow. I'm adding about 1 gallon of water per bag and mixing until the whole bag is saturated. I'll add a little bit more water as I go to help get a good consistency. This job took 2 bags of Quikrete. Normally you'd want some rebar to reinforce the concrete, but this is such a small pad without a lot of weight on it, I'm not too worried about it. I'm using a piece of 2x4 to screed the top, and then I'm going to let it sit until it starts to stiffen up. Then I'm hitting it with the edging tool, which will make it easier to remove the forms later without chipping the corners of the pad. And then I'll go over it lightly with a finishing trowel to smooth the top. Then it just needs 24 hours before we'll be ready to remove the forms. It's a hot day, so I'm putting water on the concrete every few hours to help reduce cracking. The next afternoon, I'm removing the stakes and construction screws from the forms. Everything came apart pretty easily at that point. And I was very happy with the finished pad. It'll be a nice little spot to mount our unit. For this build, I'm using a 9000 BTU mini split inverter system from Pioneer. This unit provides air conditioning along with a heat pump. We'll start with getting the indoor unit set up. It mounts using a wall bracket, but first I'm going to need to drill my wall hole for the refrigerant lines to run through. You have the option of either the left or the right side of the bracket to locate this. And I'm going to go with the left side so that the lines can run down next to the window and straight into the side of the outdoor unit. There are 2 drainage ports on the back of the indoor unit. You'll have to connect the drain hose to the one that corresponds to the side you're going to be cutting your hole on. And you'll need to insert a plug into the unused side. Next, I need to connect the signal wires for this unit. I'm removing a faceplate to give me access to the terminals. And then I'm feeding the wires in from the back of the unit until they come out of the front. The green wire goes to the ground, and the other 3 wires can go to any of the 3 numbered terminals, as long as they eventually match the terminal numbers on the exterior unit they will terminate in. I'm taking a picture so I won't forget. Then I can button the faceplate back up and get ready to attach the refrigerant piping. If you're putting the wall hole on the right side of the bracket, there's enough piping to reach outside, so you can mount the unit first and then make your connections out here. But with the left hole setup, the connection point is going to be inside and behind the unit. Since it'll be hard to get to that joint, I'm going to connect the refrigerant lines first and then pass them through my wall. I'm applying some leak guard to the connection flares. And then I'm securing the connection with a couple wrenches, being careful to not over tighten these. Then I'm wrapping the signal wire, drain hose, and refrigerant lines into one bundle that'll be easier to pass through the wall. I'm trying to keep the drain hose at the bottom of the bundle so I can prevent water from sitting anywhere in this line. And now I'm ready to drill my wall hole. I'm using a 2.5-inch hole saw, and I located this using a stencil that came with my unit. I'm drilling down at an angle so the drain line will have some fall as it passes through. Once I have this hole started on the inside, I'm moving out here to finish cutting through the siding. There's a plastic sleeve that comes with the unit, along with some putty sealant that I'm using to help keep rain out. With the sleeve in place, we're going to pass the piping through the wall. This was a little tricky with the height of our unit, but it wasn't too bad once we got it moving. For the last bit, I pulled gently on the piping from the outside, while Judy-Ann helped click the unit into its final place. So you'll notice some spacers that I had to put under the unit to lift it about 1.5 inches. When I ordered the mini split, I had a pretty big oversight in not selecting the right length refrigerant piping. I just went with the standard 10-foot kit when I really should have ordered a longer pipe length that I could cut down. I got very lucky that I was only short by this much, and by spacing the condenser unit up just this small amount, I was able to make my connections. Next, we have to evacuate the refrigerant lines. I'm removing the valve caps as well as the cap for the service port. Then I'm using a 1/4 to 5/16 adapter to connect the blue hose of a manifold gauge kit to the service port. The kit also comes with a yellow and a red hose. We won't be using the red, but the yellow gets connected to a vacuum pump. The left side of this manifold is a blue low pressure gauge, and we want to make sure that we have this valve open before we turn on the pump. The right side is for high pressure, and we aren't going to be using that for today's work. That valve should remain closed. I'm letting the pump run for at least 15 minutes to purge all of the air from the system. The blue gauge should read -30 psi. At this point, I'll close the valve and turn our vacuum pump off. I'm going to let this sit for about an hour to make sure that I don't have any leaks in my system. In the meantime, I finished connecting the sensor wire to the outdoor unit and ran the electric connecting the system to our disconnect from earlier. After that, I was still sitting at -30 psi, so I was ready to release refrigerant into my system. This is done by opening the valve on the liquid side of the system, which is the smaller pipe of the two. I'm just opening this by a 1/4 turn, giving it about 5 seconds, and then closing it again. The gauge is now indicating above 0 to show that gas has entered the system. Again, I'm going to let this sit for 15 minutes to double check for any leaks. I'll also put some soapy water on the connections, but it looks like we're in the clear. I can now disconnect the manifold gauge, and then I'm going to fully open the valves on both the liquid and the gas sides of the system. I'll flip the breaker for the circuit, as well as the outdoor disconnect. And we're ready to test the air conditioning.
Put your hand in front of it or something.
This was definitely one of the most rewarding parts of the build. After working all summer in the heat, the rest of the project felt way more achievable. With our second wind, Judy Ann is finishing the primer and paint for the walls. We went with Greek Villa from Sherwin-Williams. And now we'll start the ceiling. It's going to be cedar tongue and groove, which matches the material we have on our soffits. This is a Home Depot product. They come in packs of 6, and for the ceiling, I purchased 15 of those. In order to keep my row straight, I measured down from the ridge and left myself some reference lines. And that way I could make small adjustments as I went and keep everything parallel. As I'm getting close to the ridge beam, I have these metal brackets supporting the joists. This makes mounting a little tricky, so I had to come up with a custom solution to cap the top of the ceiling. First, I'm going to add some 2x4 mounting blocks to the bottom of the ridge beam. And then I'm going to build these side covers, which I'm putting together on the ground with brad nails. And then I'll mount them on the sides of those 2x4 blocks. And then lastly, we'll cover this whole assembly with a 1x5 cedar board. The mitered edge on these side pieces matches the ceiling slope. That way we'll have a clean transition to this ceiling cap. And the ceiling's finished. Next up is trim. We'll start with the windows. First step is shimming. I'm adding reference marks for the thickness of my jamb boards. These measurements are the amount of adjustment we'll have to make to the framing to get the finished trim aligned with our window. Next, I'm using finger joint pine to cut my shims. And then I'm using my reference marks to get all these located in the right spot. Now our window jamb will have a consistent reveal on all sides. Next we have our casing, which I'm going to build on the ground before mounting. I'm using glue and some picture frame clamps so that I can hold the miter joints together. This way I can get the whole assembly exactly where I want it without having to worry about any gaps. For the crown, I'm using 1x4, and I'm going to miter the joints to help hide the seams. For the door casing, I'm using a similar method to the windows. I'm going to glue it up first and then nail it in the final position. Before I add these baseboards, I'm going to finish the concrete floor with a wet look sealer from Home Depot. I'm going to put 3 coats of this down to help protect the floors and make them a little easier to clean. And for the baseboards, I'm also using 1x4 trim.